guys, welcome back to TechDose, and in this video we will look at the longest happy string problem, which is from Leetcode number 1405. Let's read the problem statement. In this problem, a string S is called happy if it satisfies the following conditions. S only contains the letters A, B and C. S does not contain any of the AAA, triple B or triple C as any of the substring. That means 3 consecutive A's or B's or C's are not allowed. S contains at most A occurrences of the letter A, B occurrences of letter B and C occurrences of letter C. Given 3 integers A, B and C, return the longest possible happy string. If there are multiple longest happy string possible, then we can return any of them as an answer. If there is no such string, then we need to return an empty string as an answer. A substring is a contiguous sequence of characters with a string. Okay. Now let's look at an example for better understanding. Let's say that we are given the frequency of all the A, B, C characters, and let's say these are A equals to 2, B equals to 3 and C equals to 1. Our goal is to form the longest string using A, B and C, and our constraint is the 3 consecutive same characters is not allowed as a substring. Okay, so if we look at some of the example answers that we can make, if I try to make AA, triple B and C, then are we using up the frequencies as per the availability? We have used up 2 A's and yes, 2 A's are available. We have used up 3 B's and 3 B's are available and 1 C which is available. But then according to the constraint, 3 consecutive characters are not allowed. So 3 consecutive B's are not allowed. Hence this is not a possible answer. Whereas if I just jumble this up and say that AA, double B, C, B, this is allowed. And then the third answer, which is BA, BA, BC, is also allowed. There may be other possible answers as well. So if you have multiple possible answers, you can return any of them as the longest happy string. So I think the problem is simple enough to understand. Now let's look at some observation which will help us building our solution. So the longest possible happy string will always be less than equals to the frequency of A plus B plus C. Let's look at a few examples. In example 1, we have A equals to 5. B equals to 0, C equals to 0. So our longest happy string cannot be more than length 2. Okay, and it will be AA because there are no instances of B and C. So I cannot write B and C. But if you write another A, then this is an unallowed substring. So we cannot write a AAA. So this will be our final answer. So the longest happy string is of length 2, but then A plus B plus C is of length 5. If you look at the example 2, then here I have A equals to 5, B equals to 1, C equals to 0. Now the longest happy string that I can form will be of length 5, which is AA, B and AA. We cannot increase the length further beyond this because I cannot use up the last leftover A, because if I write it on this side, it is not allowed. And if I write it in the beginning also, it will not be allowed. Right? So this is not allowed. But if you look at the first example that we saw, the total frequency was 3 plus 2, 5 plus 1, 6. And we got 6 length answer as well. So you can have the longest possible happy string length as less than equals A plus B plus C's frequency, right? Now let's look at an idea to solve the problem. We will always try to use character with highest frequency as much as we can, because we are trying to maximize the length of the happy string. Therefore, it always makes sense that we try to use the most available character as much as we can, right? So this idea is kind of a greedy approach. So if we look at an example, let's say A equals to 5, B equals to 1 and C is 0. Then in this case, if you first use B, let's say I will use B initially, then you are left over with 5 A's. Okay, this will become 0 and you are left over with 5 A's. So if you use these 5 A's, then you can only use 2A. You cannot use more A's. So the length will be 3. But can we not get a better answer? Yes, we could have got a better answer if we had started with A instead of B. Because what we should have done is, if I just append 2 A's on the left hand side where I say that I will start with A, then the length will become 5. And definitely 5 is better than the previous answer BAA. So with this, you can understand that whenever the frequency is high, then I should use it greedily. Now let's look at the second example. In this case, if I happen to say that, okay, you know what, I will be writing B and C and then I will be writing 2 A's, right? So you have used up the lower frequency in the beginning and highest frequency one you are using at the end, let's say. Then the length was equals to 4. But if you had applied the logic that where I will be using the highest frequency character as much as I can, then I will be using 2 A's in the beginning. I cannot use a third A after this. So this frequency will become 2. Now I can use a B and this frequency will become 0. Again, which one is the highest frequency one? The A. So I can put double A's. Okay, so this becomes a 0 again, and I am left with C, so I can put a C. And this is giving me a length 6, which is higher than your length 4 answer, right? So if you greedily decide to use the highest frequency character in the beginning, then that will always give you the optimal result. So let's look at one of the dry run according to that idea. Now, in order to maintain the highest frequency character or any kind of ordering between these 3 characters, you may go with your custom comparator, or you can just compare in between these 3 whenever you want to find the highest, second highest, and so on. But I personally like to use maxip because that removes the headache of comparison. So I will be using maxip in this case. Now if you have A equals to 9, B equals to 2, and C equals to 1, then if you push all these items into a maxip, the maxip needs to be arranged based on the frequency, and whatever is the frequency, if I write, let's say the frequency is 9, then we need to know the associated character for this frequency. Like 9 is saying 9 times, but then which character has to be used 9 times? It should be A. So the maxip or any comparator should have the frequency, comma, the character which is representing that frequency, right? So this pair has to be present, right? So I will be storing everything as a pair. So if you push this into a maxip, you will have 9 comma A. Okay, this is one of the node in the maxip. Then you will be having 2 comma B, and you will be having 1 comma C. If you want to know the entire internal understanding of heap and how it works, how it is implemented, then I have already made a full heap playlist from scratch. You can click on the I button or look it in the description section to go and watch that after this video. That will give you a complete understanding from scratch about heap. In this case, if I take out the first most suitable character to be used, it will be 9 comma A. So what I will be doing is I will be using this 9 comma A. So I will be pushing A, and then I will be decreasing its frequency. Okay, so the frequency will become 8, and after having done that, I will push it back into the heap. So 8 comma A will be pushed back into the heap. After this, for filling the next character, again I will be taking out the maximum, and again then A will be picked out. So I will be popping off 8 comma A. I will decrease its frequency and get again pushing it back into the heap. So 7 comma A will be going back into the heap. After that, when I am looking at the third character, like when the length is more than 2, then I have a special condition. Whenever the length becomes more than 2, I have to always check with the previous 2 characters that they should not be the same. So whenever I pick the top item now, it will be 7 comma A. So 7 comma A will be picked out. Now we have to check if A is equals to the previous 2 characters. Is it the same as the previous 2? Yes, it is the same. So if I use it again, then the constraint is going to break. So even though A is having highest frequency, I cannot use that. So I will be looking at the second highest frequency now, which will be 2 comma B. So I'll be taking out 2 comma B, and I will be using a B here, and I will be updating its frequency to 1, and I will be pushing it back into the heap. So now I have 1 comma B into the heap, 1 comma C into the heap, and again 7 comma A was unused, so it will again be pushed back into the heap. So I have these 3 items into the heap. Now for the next item, again the top item will be taken out, which is 7 comma A. So 7 comma A is taken out. We will check the previous 2 characters. Now they are not the same, and therefore I can use this 7 comma A. I will use 1A, and I will again update the count to 6 comma A and push it back into the heap. Again for the next character, again the A will be taken out, and this will become 5 comma A, and here again an A will be pushed, and this frequency will become 5, right? Again when the new character has to be inserted here, then we will take out this 5 comma A. So 5 comma A has been taken out. Okay, so we will be checking out the previous 2 characters, which is the same as A. So this cannot go. I will be taking out the next one. Now 1 comma B will always come before 1 comma C if you are using a normal comparator, because B has a lower ASCII value, right? So I will be taking out 1 comma B, and 1 comma B is taken out. I will place a B here, decrement its frequency to 0. Whenever the frequency becomes 0, then I cannot use any more instance of it. So this will not be pushed into the heap again. Okay, and this is done. This is popped forever. Now I will repush this 5 comma a into the heap. So currently I have 5 comma a into the heap and 1 comma c into the heap. I will also update this here to 0. The next two items, as you can make out, will be a, right? And so this frequency will be updated to 3 comma a, and this will become 3 as well. And the next character to be pushed, we will be taking out this 3 comma a, right? And then we will be checking that this is the current character is a. So I'll be checking with the previous two characters, it is the same, so I cannot push a here. I will be taking out the next option. If you do not have the next option, then actually you are done. But we have a next option, right? 1 comma c, we have a next option. So I will be using a c here. The frequency will be decreased to 0. And so since the frequency of c has become 0, therefore it will not be pushed back again into the heap. So currently our heap will only have one item, which is 3 comma a. So the next two characters will be a, and the frequency will be updated to from 3 to 1 comma a, right? And when the next character position comes in, yes, the heap is having certain items, but if I pop this off 1 comma a, I will be checking that the previous two characters are same, and therefore a cannot be pushed here. And since we do not have any other option, I have to stop here. And this is the longest happy string, by the way. So I hope you have understood the greedy approach of solving the longest happy string. In this case, we are doing one iteration over all the frequencies of a, b, c, and therefore the time complexity will be order of a plus b plus c, which is the addition of all the frequencies, and the space complexity will be order of 1, because we are just having 3 inputs in the max heap, right? So that is how I have written the time and space complexity. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code, I have defined a PIC, which is pair integer character, and I will be given the 3 frequencies of ABC. I will be taking the result, which will be empty by default in C++. So this is storing the longest happy string, and I will be considering a max heap, which will always keep a track of the items in order. I will be pushing all the 3 frequencies if they are greater than 0. Then I will be trying to form the longest happy string here. So this entire code is for forming the longest happy string. The first thing which I do is take out the character with maximum frequency. So, and I will be storing it in count comma character variables. And I will be finding out the size of the string. If the size of the string which we have already made is greater than 2, then the current character whatever we have, it needs to be checked with the previous 2 characters, and if they turn out to be the same, then we cannot push the currently popped max heap item, but we have to consider the next character which has to be put there according to our dry run, right? And then we will decrement the next character's frequency and push it back into the heap. Otherwise, if the current character is not matching with the previous 2 characters, then I will simply put the current character. Okay, so I will be pushing back the current character and decreasing its count. And after entire thing is done, I will be checking if the top of the heap which was initially popped out is actually having a frequency greater than 0. Then I will push it back into the heap. We will not push any item with frequency 0 into the heap back again. And finally, after this entire process is done, we will be returning the result as longest happy string. I hope you were able to understand this solution. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.